So here we've got a radio in from a end user. It's a Realstic TRC2005, which is the same as the Maxon MX1000. A customer wants a mic for it. In fact, he's done as a swap. And the date code is June 1990. These are very reliable, and I've never known one go wrong. So I would think this is a tune-up in 20 minutes. We'll use our standard replacement mic off the shelf, but we have these ready made up for this type of pin-out, hopefully. Right, that's that. So CPT FM only. I think there won't be anything wrong with it. It's a matter of a tune-up. Cool. Did I bring the sheet of paper? I did. I also brought the squirk kit diagram. That's all we've got, which is a bad photocopy. Multiple generation one from a German website. So it's 1990. So we'll just go through it. Put the power supply on, 13.8 volts. It would be sensible to connect it up. At least it doesn't boot up on some daft channel like 9. Picture in picture on, and the keys up. It's doing 3.3 watts. Okay, where's my pen gone? We'll be generous and say it's doing 3.4 watts. Take half a second to key up. 3.2 watts on channel 1 and 3.3 watts on channel 40. Don't have low power, it's not a 2781 set, it's CPT, so the frequency should be, of course, be 27205. We won't be doing the VCO, but we will be doing deviation. Just do a quick check on here, and we're on the wrong meter anyway. I'm going to have to retune this. Wow, it's actually saying 3.5, so it may be true. Put that kind of in brackets. Let's look at the frequency. Test set's been on for a good half hour. 27, oh, we're still on channel 40. 27,205.17, it's spot on. Good start. When we key up, the power meter says all the bars. It doesn't have a meter lamp. Works, doesn't have supply. We'll come back to the speed. Alright, we'll get that dialed in on the signal generator. It's like changing the destination on a bus, this. 27,205. I can hear the signal generator. So CPT doesn't work for us around here. We can do on the air test and have to change channels 8 times, you know, it's no good. So, let's put 100 microvolts on the signal generator, and it's saying 3, whatever that means. That probably means S9. So it's probably right. Right, let's have a look at the cyanide. It's certainly what it's supposed to do, 0.66. For 10 dBs, 0.55. And for 20, if it ever does it, it does, it's 1.45. I like tight squares to be 100 microvolts, but there's no rule about that. So let's put the attenuator up on the inset picture amongst the junk. So 3, 10, 30, 100, 300. It is coming in at 310 microvolts, so it's a bit too tight. But so that's just the way my experience and training is. Right, so we'll do the opposite now, and we'll set the threshold on the radio. The signal generator has been parked at 0.3 of a microvolt. Put it back on. And we've got 0.56. So if you just bought this set on eBay, the only thing which is I'm not happy about is that we'll be checking it on the test set behind me. Slightly down on power, virtually spot on free, because we're not, you know, we'd be just messing around the edges there, and the receiver is within spec, so it looks like a reasonable working set. So I'll open it up. I'll put the soldering iron on. We've probably got to detach the speaker. I think this came like the day before Christmas. Might be able to not have to detach the speaker. Crystal filter, because the specification demands that. I've shown these sets before, but I think under the Maxon 1000 guise. Trying to read that service information is not easy, so we'll try and work it out without. I could look at my paperwork from the Maxon, but it'd probably take me 20 minutes to find it, so we may as well do the set full stop. So I can see our detectors there. I would suspect that they're either both meter, or that's probably deviation. There could be one of these, could be power on this set. That's probably the meter on receive. Sorry, on transmit. And it is. See? So that's TX meter. Unless it's power, which I doubt. No, it's definitely meter. just trying to find these presets. We've got S9 on the signal generator at the moment, so I would suspect that one of these is going to be a meter. Again, is it that one? That's the meter. So transmit meter, receive meter. Is that going to be squelch? Let's see, put the squelch on. And just this one. That's squelch. So RF meter, receive meter, squelch. So we're going to have deviation. So that must be power. That must work that way. So key up. Let's go back to the main meter. And it's power. Good. So we'll pop that up to full whack and tune the transmitter. So we're looking for the peak of the centre of the peak. That centre of the peak. Spent a lovely evening watching somebody's camcorder video. Bought a broken camcorder for 99 pence and sorted it out. And it was one of those ones that takes DVDs, little 8cm DVDs. And it was somebody's holiday in Wales to young ladies. So I sat watching that. Nothing naughty, nobody's bedroom pictures or anything. But you think, why did they leave that in the camera? It must be about 2002, so it's 20 years ago. So we're spot on the 4 watts there. So let's see what it is on the other channels. So on channel 40, it's 4.05. Channel 1, it's 4. So I've got, it's 4 watts. I'm going to put 4.01 and 4.05. So these, of course, don't do low power. I never took what the current consumption was. Not that it matters, but that is something I normally like to do. It's 1.2 amps. So where it was before might have been a little bit less, but then we've retuned it. It might have not, and that's why we like to have a check. So we'll come back to the deviation, do the frequency. So it hardly wants touching, doesn't need touching, but just for the demonstration. 2720516, it's so close. 2720508. Let's leave it very slightly high because they drop with age. 2720508. So that's that done. So the RF meter, I still want it to read 4 when we transmit. And it reads 2 at the moment since I messed with it. So we'll just set that to just 4, not over the top full whack 4. Then at least if you've got an SWR problem you can see it occurring. So it's reset, so we'll do a tick. Alright, let's have a look at the receiver. That just sounds a bit harsh to me. I might be wrong. So put the oscilloscope on, switch to camera 3. That's our best peak. So that was marginally out. So now we'll do sensitivity. Go through the receiver and work the cyanide meter. So this looks to be the front end. This is going to be the IF. You see the crystal filter there for the 10.695, the ceramic filter and resonator for the 455. So just drop the signal a little bit on the test set. Got about 5 dB there. See whether we can gain anything. Is that somebody at the door? Okay. No, it's my imagination. It's probably the rats and mice in the loft. So that's worse. That's worse. So where it was exactly right. Could be a tiny, tiny improvement there. Well, that's spot on. Let's put a bigger signal on for this one. That's it. So is it better or is it worse? See, the fact we've done the detector can mean it was over. It can be more sensitive with the detector out, but of course everybody's garbled. Yeah, I'm not far out there. Yes, it's 0.81. Not 0.63. Not 0.38. Sorry, 1.38. I've gone through it several times and just turn the volume down. We've now got 0.68. Which of course isn't far off where we started from. 0.56. And 1.15. So you can see the quality of the signal has increased dramatically and the sensitivity is now nearly as it was. So that's good. Now the squelch performance will be totally different, I expect. Squelch, very clunky squelch. So squelch, put the attenuator up. 100 microvolts. Let's get that reset. That's now how I want it. Let's turn the squelch down and take the signal generator off. Park it at 0.3, switch it back on. Well, that didn't work, did it? Just see if we can set that a bit more carefully. 0.68. Right, that leaves the S meter, so put 100 microvolts on the signal generator, and I expect it's going to be 3 bars, but what I want it to be is not quite 4. So we said that was going to be the S meter. Right, well, that's fair enough. So S9 is the third one. So although it was right before, I have adjusted it. Let's do the deviation. So plug it into the test set. So we thought it was a bit high on this test set. So we'll see whether that's true. Wow. No, it's not true, it's 2.1. Wallow, wallow. There we go. So it was 2.1. It's now 2.2 to a peak of 2.5. So it was, if we put it the other way around, it was like 1.9 to 2.1, 1.8 to 2.1. So that's our kind of average, and that's the absolute peak, 2.5. 2.5. There we go. So there we are. So I've not hurried it, but there was nothing wrong with it, just needed a tune-up. So we'll do a scratchy corner test. We'll send it out with a brand new mic, exactly the same as this one which we do the testing with. So because we're putting the plugs on, it'll get the posh metal plug. So the 5-pin DIN mics you can buy are going to be wired for Maxon 4E type of 5-pin DIN. I've known people buy them expecting they're going to work with their Cybernet chassis sets, like the Barracuda, the bigger Barracuda, not the great Barracuda, or the Sapphire X4000, or the Oscar 2, SMC Oscar 2, but they're not wired for that. They're wired for Maxon 4Es and things. So there we go. We're all done. Let's have a flick round, and all that'll be on is interference. Check its own speaker works as well. And a Roger. Bearing in mind it takes half a second to go into transmit. Let's try 1-4 Roger. 1-4 Roger. No, well, I'll leave it on there, and we'll get the bench cookie thing, and there we are, we're all done. So Nothing wrong with the set, just need a little bit of a tune-up, and we're now at full 4 watts, and although the sensitivity is more or less the same, we've sorted out the fact the detector was a bit out, so it would have been a bit garbled. Anyway, the proof of the pudding's in the eating, and we'll do a scratchy corner test pretty pronto. Thank you for watching the Realstic TRC2005, which is the same as the Maxon MX1000 from 1990, a CEPT FM only 40 channel set.